Good day, everyone. Today we'll talk briefly about unions, intersections, and complements. Just very briefly, some terminology before I do some examples. The first thing that we want to talk about is a union, okay? And a union of two sets contains all the elements contained in either set or both sets. So the notation is this upside down U. A is the union of B, okay? So that means that if we have two sets, okay, then elements in set A, okay, should be in set B, okay? They share commonality of each other. So when we have some elements that are in one set or the other set, that is a union, okay? More formally, it's better if you understand the formal definition, because if X is an element of that union, which is A and B, if X is an element of that union of those two sets, that can only happen if X is an element of set A or an element of set B, or both, okay? So that would give you a better breakdown of how it works, because sometimes you do see that formal notation than simply A with the U and then the B. So I'm going to give you both notations so that, when you see it in another class or just, a different book or something, you won't be confused. You'll be like, oh, that's the same thing as this. An intersection, think about it, is that the intersection of two sets contains only the elements that are in both sets. So the notation, as you can see, you have, I think this is an error here. Okay, I meant to put the upside down U here, so I'm going to have to clean that up and rewrite that as A upside down U B. There we go. Now we're in business. Okay, so again, if you want to find the intersection of two sets, that contains only the elements that are in both sets. So A upside down U B, that's the standard notation. A more formal notation would be that, well, if X is an element of that intersection of A and B, that can only occur if X is an element of A and, notice the key word, and, okay, and is an element of B. So if we have something that's part of set A and part B, that means it shares commonality with both of those sets. Unlike the union, if you have an element that's part of A or just part of B, or it can be both, okay? So that's the difference between these two. And then a complement of the set A contains everything that is not in set A, okay? So the notation at the bottom here is either A prime or A with a little c to the upper right. And sometimes you can see it with an A with a little tilde to the left. The most common notation that I have come across is the first two. You see that more than the third notation based on my experience. But I figured I'll just list all three, because you could be reading one book on set theory, they could be using that first notation. You could pick up another book on set theory, and then you'll be like, hey, wait a minute, this is a different notation, but actually it's the same, it's just a different way of writing it. Or you can pick up a third book of set theory, and then you'll have a different notation. So keep in mind that in mathematics, you can have several different types of notation that mean the same thing. So just be aware of that. But let's do some concrete examples, okay? This is just, just a basic definition. So let's go ahead and use a couple of examples, okay? And we'll make it kind of fun. We'll just do we'll do this, okay? We'll call the first set, and we'll use colors here. We'll use red, green, and blue. Okay, just an example. And we'll let set B represent red, yellow, and orange. And we'll let set C represent red, orange, yellow, green, blue, and purple. Okay, so we have 3 collections of colors. All right, A, B, and C, and we're going to do this. We're going to find, for example 1, we're going to find union A and B. Okay, so the union, we want to find, the union contains all the elements in set, in either set. Okay, we want to find all the elements in either set. Okay, so how do we do this? Well, we'll look at the original sets that I gave you, and we'll look at the first set, got red, green, blue. The second set, B, which is red, yellow, and orange, and then the C is red, orange, yellow, green, blue, and purple. So if in order to find the union, then we notice that we have red, green, blue. So we want to find all of the elements, or all of the elements in this case would be colors. We want to find all of the colors in either set. Okay, so when we do that, that's going to be red, green, blue, yellow, and orange. So we're listing all of the elements in either set. That's the key thing, okay? We are listing all elements in either set. And 2 sets we're talking about would be A and B now, right? We're not worried about C just yet, okay? So make sure that you do the right union here. We want these 2 sets only, okay? Not all 3. So we're focusing on set A and set B only, okay? So just kind of block out set C for now. Don't look at that. Look at the first 2 sets. Well, if you want to list every element that's in either set, you shouldn't be repeating elements, okay? Red exists in all 3 sets. Great. Green has to be represented. Even though, I'm sorry, back up here. Well, see, I got attracted to the C here. We want sets A and B. So red has to be included, okay? Green has to be included, but you notice red is only represented 1 time, not twice, okay? We don't repeat elements more than once. That's not necessary. So we choose 1 red, okay? Green has to be represented. Blue has to be represented, okay, even though it's not in both sets, all right? We're not looking at that. We just want to represent all of the elements in both sets without repeating, okay? So we go red, don't repeat red, okay? Green appears once, blue appears once, yellow, and then orange, okay? So the key thing is here, you list every element that's in both A and B, but don't repeat them. Very important. Don't repeat redundant elements. Okay? And then you would just use the notation. You're going to use the braces because that represents a set or a collection of elements. and then you write down the elements that are in both in A and B, because we want to find the union of A and B, and list them and do not repeat elements. Okay, so it's pretty simple. The next one we're going to do, okay, next example is we're going to find the intersection of A and B. The intersection is the upside down U. Okay, so be careful, because you see how I wrote the right side up U last time? It's so easy to lose track because you have all this mathematical symbols you're using, and I can see where it can be a little overwhelming at times, so I totally understand that. As long as you catch it and go back and say, hey, this is how it should be. So we're going to find the intersection of A and B, okay? Again, we're not worried about C just yet, okay? So, and the intersection means that we want to find all elements that are in both sets, okay? So we want to find all elements. We want to find all elements that are in both sets, okay? So here's how we do that, all right? I'm going to use our braces, okay? If you look at set A and B on top, what color appears in both sets? Well, the only color that appears in both sets would be the color red. Red is represented in set A as well as in set B. So we're going to choose one of those to represent. Oops, okay. Let me go ahead and write that a little bit better, okay? All right. Again, you just write one. One represents both of them. You do not write redundant elements, okay? So let's go back to that. What are we looking for? We are listing all elements in both sets. Okay, that's the trick there. All right. Well, red exists in both sets, so we just write one of them to represent it. You don't need to write red, comma red, because you only write it once. All right. The last thing we're going to do is do another example. It's called we're going to find complement. Okay, complement. And what do we say a complement was, right? You're looking for all the elements that are not in set A. Okay? Excuse me, let me go back here and fix this. I wrote it twice, I apologize. Sorry. We want to find the complement of C. So, the complement of A. And what that means is that we're looking for all elements that are not in that set A. Okay? And are also in C. So we are looking for all elements that are not in set A and are also in set C. Okay? So that is what you would need to write. That's what we need to identify. Okay? So again, if you look at the set A and set C, you notice that we have, let me list the colors here. Orange, and we have yellow, and then we have purple. All right. Okay, so let me write this down first. This is what we're looking for, so you understand what I'm saying. Okay, so here we are listing all elements that are not in set A. And are also in C, okay, in set C. So what does that mean? Well, let's look at it, okay? Let's look at the first statement. We are listing all elements that are not in set A. Well, look at set C. What colors are not in set A? Well, orange, yellow, and purple are colors that are not clearly in set A. So we want to list those in the little braces, okay? And if you also look at the second statement, they also have to be in set C. Well, orange, yellow, and purple are not in set A, but they're still in set C. So the answer is orange, yellow, and purple. Okay, that's what the complement of something is. All right? Okay, so I hope that this clarifies some things. And I hope that you'll have a good understanding of what these are. The next time I'm going to talk about Venn diagrams, so we can see some pictures of what intersections and unions are, and we'll do that in the next lesson. Thank you so much for watching my video.